the product development team. He has been handling and is handling performance related items in the application server. He has handled several customer engagements in the performance area that relate to scalability and high availability. And today he'll be talking about the common problems you might face when it relates to WAS performance, and also around the IBM Support Assistant and the tools that are available for problem determination. So welcome aboard on this afternoon session of the WAS virtual event, and over to you, Vishal.
Lavi Verma.
Yeah, thanks, Lalita. Pratap from Noida.
Now departing.
Good afternoon, everyone. My name is Vishal Charegaonkar. I'll be talking about the session on WebSphere application server performance.
Now departing.
So whoever is on the phone, can you just go for the mute? I get a lot of background noise. Getting a lot of noise.
Unidentified participant.
Yeah. So I'll begin my presentation. As Lalita introduced, I work for the WebSphere application server. I have been working on WebSphere performance and performance tuning sort of issues for last almost 6 years. I handled many customer situation and have seen a lot of performance related issues. So in this today's presentation, I will be sharing some of my real-time experience. So we will talk about the WebSphere App Server top 10 performance best practices. So we'll touch base with the important performance parameters. Then we will talk about various monitoring tools. To monitor your performance parameter, as well as the problem determination tool. So these are some of the tools which are very useful for end customer, and I'll be talking about it. And that's the reason we are calling this as a WebSphere performance workshop. So it is not only the performance tuning tips as such, it's a tips as well as you will have lot of information on the tools that IBM has. And whatever I'm talking here, all the tools that I'm talking in today's presentation are all free tools. I'm not going to talk about any tool that end customer has to purchase. So all these tools are available for you on IBM website, and it is free for use. So let's begin our top 10 performance best practices session first. See, when it comes to WebSphere performance, many people ask me the question as, give us some standard formulas for the tuning. And, it's not exactly, there's no such formula. I mean, if you know the way how App Server works, how the application get deployed, and how the application works inside the App Server containers, see, you will not be really able to get any standard formula for the tuning as such. There are basically three main characteristics or three main criteria for tuning your application, and these criteria are each application will have its own characteristics. So how your application is, what component application uses, or what is the architecture of application. That's one criteria. Second will be the amount of workload that comes on the website or that comes on your application. See, workload differs for each and every application. You know that. If it is a online transaction application, there will be certain pattern. If it is some kind of message processing application, there will be certain pattern. If it is a teller kind of bank teller kind of situation, there will be some different user pattern. So it depends on the amount. It depends on the workload, what type of workload and how this workload comes into picture. And third important criteria is the hardware. So application, workload, and hardware. These are the three important aspects of the any application server or tuning consideration. And you know that all these three varies across server or across application or across various use cases. And hence we cannot really give you any standard formula that put this as value A, put this as value B, and then find out what is the value C. So there is certainly a methodology involved. So you need to understand a little bit theory behind this WebSphere application and how it behaves and how the container works. And once you understand some of the standard behavior or standard tuning parameter, you will be in position to tune yourself, and you will at least be in much better position to understand what's happening and where to look for any performance problem. So with that, we'll begin with our first or 10th point. I put it in the descending order. There's no reason really. All 10 are equally important, but just others. So if you look at the point number 10, understand and tune the infrastructure holistically. So holistic view is something which is very important. See, many times we find that we start debugging problem at the WebSphere level or application level, thinking that there is some issue, but that's not the right approach. First look at the overall picture of your application. See, we are basically looking at the end user. Much is bad, end user is suffering, right? So we need to see how end user get the best response time or best throughput kind of thing. So in that case, you need to look at all the components that are involved in this transaction. So in this picture, you will see that the request goes to HTTP server, then it goes to application server, then it goes to host, which is a database. And if there is any problem in any layer, end user is going to suffer. So our approach is the end user should get the proper response time. And in that case, you need to really understand where is the bottleneck rather than directly starting or debugging at WAS level or database level. And how do you do that? Then for that, you need to know some of these system level tools. System level tools I'm talking is specific to operating system. And basically, you are trying to you should understand the CPU utilization, memory utilization, and disk I/O. So if you get this hardware utilization across setup, you will be able to identify where the problem is there. I'll move to next slide, which is slide number 3. In the same point, when we talk about the holistic approach, again, before getting into WAS level or any specific level, understand what are happening on that machine. If you have a WAS machine, see if there is only WAS app server runs there, or is there anything else is running. I have seen many instances when the problem is because of some other process, but entire WebSphere user suffer. But you need to understand whether it is the different process that is running or it's only the WAS app server that is running. Also, look at the database side, understand whether the database is properly tuned. If you have a cluster kind of setup, understand that the load on database is going to multiply by number of the cluster members, and make sure it is properly tuned. And at the last of your infrastructure is going to be the storage subsystem. And storage gives you much better performance if you have configure it rightly and have a good storage at your backend. So understand everything and make sure you are comfortable that everything else is tuned properly and there is a problem in the WebSphere app server. Then probably you should. The storage that I'm talking here is just for the data storage. Okay. But it involved in the end user transaction. That's why I wanted to touch base it. So I'm moving to the next point, which is JVM. So the important part of application server, WAS WebSphere application server, is a JVM because it is the core. The WAS runs on the JVM. So it is very important to understand the JVM and make sure that we have properly tuned the JVM. Getting into little bit into JVM operations, I'm sure you people are aware of garbage collection. So garbage collection is a process of collecting the references which are no more required. When the object is being let's say the object is allocated for certain use, and when the use of object is over, the object is no more required. But if but JVM does not clean the object immediately from the heap. And if you see the right side, there is a small diagram. So whenever there is a new object created, it gets allocated in the heap, but it will not get removed from the heap immediately after it is being dereferenced. So what happens as soon as you reach the minimum heap, or you reach to the, if your minimum heap is occupied, then there is a garbage collection event. There is a garbage collection event, or there is a allocation failure event, and then garbage collection runs. When the garbage collection happens, it cleans all the dereference objects. So all the objects which are no more required in the by the JVM will be cleaned up, and this process is called as the garbage collection. So what is the biggest impact of garbage collection on application? So when garbage collection happens, all the application threads are frozen, or we call it as a pause time, or there is a pause in the JVM entire. So it is very important to understand how much time garbage collection takes. If it is taking time in seconds, if it's taking 2 seconds, 5 seconds, it is really a bad sign. The application will wait for garbage collection to complete. So when you want to tune the JVM, it is important to tune the garbage collection. So there are various GC policy that IBM WebSphere Application Server allows you to configure. So these GC policies are like opt throughput, then there is a opt average pause, then there is a GenCon. GenCon is something which is introduced recently, or it is introduced in 1.5, and it is a default policy for WebSphere 8.0. So basically, based on your application criteria, you can choose the correct GC policy. See, by default, opt throughput is the default GC policy, but you can change it based on your application. And as the name suggests, right, it's opt throughput is optimized for throughput, opt average pause is optimized to pause, and then GenCon is actually combination of both. So when it comes to the GC tuning, you select the right GC policy, and then you select the right heap size setting. When you set the heap size, well, let's say when you set maximum heap size to a very large amount, what happens is during the application runtime, it keeps allocating objects till it reaches to max heap size. But when it reaches to max heap size, then there is a GC get triggered, and it cleans up your entire heap. And in that case, if it is heap size is too large, it takes long time to clean up the heap, and the pause will be significant in that case. So it is not recommended to set up a very high max heap size, and ideally it is better you do this kind of operation during the performance test time. So you can try it couple of policy and then see what work best for you. How do you really select the GC data, and how do you analyze? I think that's one of the question I keep getting in from a lot of customers. For that, I will move to next slide. See, there is a feature by JVM which is called as a verbose GC. When you enable verbose GC, it dumps all the garbage collection or all the GC activity into a standard log file, which is called, in WebSphere case, it is a native _std err.log file. In WebSphere admin console, you will find the JVM setting, and you can enable the verbose GC there, and it will dump all the GC data into a native std error file. This file, if you open, it is kind of a text file. It's a sort of XML file. You can read it and you can understand it also. But we are providing a tool to understand this GC data. This tool is called as a garbage collector memory visualizer. And once you load this once you load this verbose GC file, it will give you a graphical representation of your GC data. The verbose GC Yes. Yeah, it is a verbose GC data. It is a verbose GC. Correct. So when you now you are looking at the screen, you will see that there is a screenshot, and this is actually data collected from JVM, which ran for like somewhere around 50 minutes. You can see the x-axis from 0 to 50, and you will see that there are only two lines. One is a green, which is a used heap, and one is a blue, which is a total heap size. So you'll see that heap size is somewhere around 96 MB, but used heap is increasing from 40 and it went almost till 60. This tells me, there is so GC is behaving sort of okay, but there is a sort of leak here. By looking at the used heap, I can see that memory is being leaked here. So that kind of information also you get it using this tool. On the right side, you will see the selection panel, and you can select as whatever you want. You want to select what is the total pause time, or what is the small object area, large object area, anything, any detail you will be able to see in this chart. There is a recommendation panel also on this tool. I am not included in this screenshot, but looking at the recommendation, you will know what is going on, and you can take some call based on the recommendation provided by this tool. So before moving to next point, I want to introduce some more tools. Basically we have IBM has a IBM Support Assistant. It is a standard workbench we provide many tools using this standard workbench. If you go to IBM website or IBM support site and search for IBM Support Assistant or ISA, you will know you will get a link for this workbench. And once you install this workbench, you will be able to download any of these tools which I am talking here, like GCMV is one of the tools. I will show one screenshot towards the later presentation, but I just wanted to introduce this ISA or IBM Support Assistant. It will give you a lot of tools for your problem determination. So let me move to our next point. HTTP session content. This is also one of the important area, and I have seen lot of issues, especially out of memory issues, because of the HTTP session content. This I am talking about the session data that application stores in the user session. Make sure this session data is as low as you can, as low as you can keep it. I mention here as 1 MB, but that's not really a good figure also. It depends on your application. It depends on your application and how many users are connecting to your application. Let's say you have one server and you have, let's say 1,000 users connecting to that application server. And if each user is having 1 MB of data, then we are talking really about 1 GB of session data. In that case, your heap size is going to have a problem. So make sure that heap size, the session data is low, and we really recommend to have it somewhere in the KBs, like 10 KB, 30 KB is sort of okay. But going beyond that, you need to be very careful. You need to, because when the data is in the heap, it's just going to occupy that much space, and your JVM will have an impact. And I have seen many customers having out of memory issue during the peak period when there are a large number of users connecting to their site. So there are the standard guidelines. Again, I cannot say that this is the best size, because again, if application needs certain data, then it has to be there in the session. So make sure you understand the methodology, and then you take a decision what will be the right session size. But make sure you store the critical information in the session, and the other information you can cache somewhere in the app server, or you can retrieve from the database. session data will have another impact when you want to replicate the session. The WebSphere provide you multiple way of maintaining session data across multiple servers, session persistent I would call, so that if one server goes down, when the request goes to some different server, it should be able to retrieve the session data. So there are various techniques provided by WebSphere. One is memory-to-memory replication. One is keeping the data into the database itself. That is called as session persistent. But if you are using memory-to-memory replication and if your session size is large, then again there will be impact on the memory, because you are now storing your own session as well as you are storing sessions from the other JVM also. So there is going to be a impact on the JVM operations. Now the question is, how do you monitor this session data? What is the size of my session data? How do you know that? So that's where we rely on some of the tools that WebSphere itself provides. And these tools are PMI and TPV. Those who are working with WebSphere, I'm sure they know about PMI and TPV, but those who are new to WebSphere, let me elaborate a little bit. PMI is a performance monitoring infrastructure. It provides you a capability of each and every component of WebSphere application to collect the performance data and show it to the end user. And the viewer is nothing but called as a Tivoli performance viewer. So all the performance data that is collected by WebSphere can be viewed in the Tivoli performance viewer. And Tivoli performance viewer, even the name is Tivoli performance viewer, it is not really any additional tool that you have to buy from Tivoli. It is a part of admin console, but just the monitoring strategy is we have a Tivoli as a main monitoring tool provider, so the name is there for Tivoli performance viewer. But this is part of admin console. If you go to admin console, on the left navigation side, you will see there is a monitoring and tuning section. You will be able to open Tivoli viewer using that. So PMI, which collects the data from each component, so you will be able to see on this right side of the page that some of the example of PMI data. If you are talking about the servlet container, the web application, it will give you what are the servlets are registered with that web application, how many hits have occurred to each servlet, and what was the response time for each servlet. Same data is available with EJB and EJB methods also. Regarding thread pools, it will tell you that how many thread pools are there, what was the pool size, what was the active threads, and what are the free pool. All that information you will get using the PMI. Then beyond that, it gives you the JVM level statistic, what is the used memory and what is the heap size, as well as the OS level, it gives you the CPU utilization. For each and every component, you will get a lot of performance data using PMI and TPV. By default, basic level is enabled, and now also if you go to your app server, and if it is the default setting, you will be able to see the performance data which is collected at the basic level. There are certain data which is not collected in the basic level, and there are reasons. Some data are not collected because of the performance overhead, or some which are like detailed debugging data, which is not really available in basic. Session size is something which is not available in basic, but if you want to monitor, you can go to custom level, enable specific session size, and then it will start collecting the session size data. You don't need to restart the server for this. So that was a bit a short overview on PMI and TPV, which are the built-in tools, or which are the out-of-box tool from WebSphere application server. Moving to next slide. Another important aspect of tuning is to tune the thread pools. In WebSphere, there are many thread pools. The key one are web container thread pool, then there is a ORP thread pool, and then there is a default which messaging and other components use that. So with this thread pool, now the question is, why do we have thread pool? What is the advantage of having thread pool rather than creating thread as required? So there are two advantages you get from the thread pool. One is you don't have to create the new thread and then assign a work to that thread and get it run. So you avoid this unnecessary call of creating new thread, destroying new thread, and all these life cycle methods on this. Second advantage you get by using thread pool is to you can regulate the work that is coming to your container. See, if I have web container and I have a web container thread pool, I will make sure that only X number of threads can run in the web container because my hardware can support only that much. So that kind of regulate I can do the so that I will serve the request effectively. If I make thread pool size very high, or let's say there is no thread pool, all the requests will come suddenly in the web container thread pool, and suddenly you may see the CPU reaching 200%. And because of that, none of the requests will really able to make successful. And with the thread pool, you can control that. With my hardware, I can allow only X number of concurrent requests, and with that, you will be able to achieve the peak load or any sort of load you will be able to serve it. Those are the two benefits you get it with the thread pool. So it is very important to tune the thread pool. Again, there is no formula to tune the thread pool. So it depends on two factors. One is how much is your hardware, how much is hardware is supporting, and how many concurrent users you are getting. So by default, the thread pool, at least the web container thread pool, by default the max size is 50. So what I suggest is, keep max size as 50 and do a performance test and understand how all the users are behaving. If you see that CPU is still available, then you can increase from 50 to 100 and then see how is your CPU and the users are behaving. So based on that criteria, you need to really tune the optimum value for your thread pool. Again, there is no formula to tune it, but it depends on your application and it depends on your hardware as to find out the optimum value. But it is important to understand this methodology or concept behind it. Now, when you tune it, how do you monitor the thread pool usage? Again, as I said earlier, PMI and TPV are our tools in our toolbox that will give us the information. So on this screenshot, I am at slide number 9. On this screenshot, you will see that so you will see the web container thread pool is being monitored, and active count, which is in the red, and the pool size, which is in the orange, are being displayed. So here you will see the active count is somewhere between like 20, and whereas the thread pool size has reached to somewhere around 40. So I have not really exhausted my thread pool. So I am okay with this setting and I can continue with my application. So I'm moving to the next slide. How do you, I think this we already spoke. Basically you monitor active count, monitor hardware backend utilization, increase or decrease the thread pool based on that criteria. Moving to next point, which is connection pool. So basically you tune your JDBC data sources. As we spoke about a thread pool, the same concept are there for the connection pool. So connection pool is a way to regulate your work to the database. So it gives you again the same two advantages. One is creating connection and destroying connection is something you can avoid by keeping a connection in the pool. So you can reuse the connection. Second advantage you get is to regulate the work to your database. So if your database is able to capture or able to execute certain amount of work, you can tune it such a way that only that much amount of work goes to the database. Or in case of cluster kind of environment, you may want to make sure that the database work is distributed evenly across all the cluster members. So you can do it using the connection pool. Monitoring connection pool is again with the same way as we talk about the thread pool. It's like PMI and TPV. monitor the TPV and understand how is connection pool being used. So these are some of the key metrics that are available with the PMI. Free pool size, then there is a use time. Use time will give you the how much time the connection being used by the application. So if application is creating connection and using it for longer time, you will know that it is that time you will get it here. And then there is a waiting thread count. Let's say your pool is not enough. Let's say you made maximum pool size as 10 or 15, and your web container size is like 100, and they are not able to use all. I mean, they are not able to connect to database because all the connections were utilized. In that case, your waiting thread count will start increasing, and that is the value you will get here. So when you see there is a waiting thread count, that means the connection pool is not tuned optimally. And wait time is the average time thread wait for connection to database. If wait time is increasing, again it's not a good sign. So these are the three important questions that you should ask yourself. How busy are my threads in the connection pool for this workload? I mean, whether my connection pool is being utilized always, and then there are no free connections. Then how many threads are waiting for connection? As I said, right, you should not have any waiting thread. When there is a waiting thread to get a connection, there is going to be an impact on the performance of or the response time. So wait time should be very minimum, or ideally it should not be there. This is again how do you monitor the data source. So here you will see that your thread pool size was very small in earlier case. It was only 10, and sorry, connection pool I'm talking here. It was very small. It was 10, and then there was in the right side we have increased it to somewhere around 40, and because of that, here you will see that end user response time is impacted. If there is, you will see there is a waiting thread count is quite a bit in the first chart, whereas in the waiting count is 0 in the second screenshot. I apologize for the screen. It's not very properly visible, but the idea of this screen is when you have a smaller connection pool size, there is a waiting count. When you increase the connection pool size to 40, the waiting count becomes 0. And that's how you increase the performance of your system. Moving to next point, which is use application best practices. This is something which I have seen in most of my customer engagement, that a lot of application level tuning is required. Or a lot of issues can be avoided if application uses best practices for performance. So I'm not going to talk about all these points, which are like maybe 20 points here, which will take another hour. So what my point is, there are many guidelines, or there are many such points that application developers should follow. And once he follows, then we can avoid, surprises in the performance test or in the production environment. So make sure, you use some of the standard best practice. There is one Red Book provided by IBM. The name of the Red Book is Designing and Coding Application Performance and Scalability. The link is given in this presentation. You can click there and then you can download this Red Book. This is really very good Red Book. Then some of the important points from application perspective which impact performance directly is your logging level. Make sure you write a log whenever it is required. Avoid the excessive logging. One example is given here. Initialize variable when you really require it. So if you have some kind of if condition, and most of the time, let's say you are going to skip this if condition, then initialize variable only inside it. If you initialize outside, you are unnecessarily holding a memory, or unnecessarily holding this strings. Then there are some good point about lazy instantiation, or using the object pool. So avoid creating objects again and again. This is required if you have like lot of short-living objects and which are like of the same type. Synchronization, can I avoid? I'm not saying that synchronization should not be there, because there are application requirements and they may have to use synchronization, but try to avoid as much as you can, because synchronization is sometimes the area which causes the server hang or crash kind of situation. Moving to next point, profile your application. There are a lot of profiling tools. Now, when I say profile application, I am talking here about understanding the application methods or understanding application code which is causing more CPU or which is taking more time. So there are various tools available. So there is a RAD profiling, ITCAM has it. Health Center is something which I am highlighting here. And in next slide, I have a screenshot about Health Center, which is which is part of IBM Support Assistant. I have few slides at the later stage. If time permit, we'll quickly go through those slides also. But make sure you take the transaction which are more important or which are highly used. Some kind of 80-20 rule you apply and use the top 20 use cases and do the profiling for that use case. Moving to next slide, which is I'm on slide number 17 right now. This is one of the screenshots that I captured using Java Health Center. Java Health Center is a tool that is available free of cost to all of you, and it is available using IBM Support Assistant, again ISA. So in this case, I started Java Health Center, connected to running WebSphere, and profile my application. I have seen that my application is always 100%, and then in that case I connected and tried to find out which are the method which is taking most of my CPU. Here if you see, I have applied the filter called com.moneybank. Moneybank is just a small sample application. When you apply that, you can filter it based on the application level code. Here it says that there is a method called interest rate calculator, and that method is taking somewhere around 88% of my CPU. So I can immediately go and look at that method and see what is wrong in that method. So it gives you a very good amount of information as a profiler. We'll get into detail if time permits. I have 4 or 5 slides on the Health Center itself. We'll see that one. Caching is another. If I'm talking about the performance and if I'm not talking about caching, I think it is something not good. Caching, from application level, you can certainly implement caching by best practices in application code, but there are additional caching solutions that IBM also provides. For example, DynaCache is something which is available with WebSphere. So you can use DynaCache and cache the data. You can cache the data across cluster also. So basically there are multiple way of caching. So one is maintain data in the same JVM. Then you can have a DynaCache and you can replicate data across the cluster member, so that once the data is cached in one app server, the data is available to other app server also. And the third one is about the extreme scale. If you really want high performance, this is really a good solution to use extreme scale, where the data is cached in same JVM or multiple in separate JVM, and then you can replicate or you can increase number of JVM as your data grows, and there is no limit as how much data can you store here. You need to have some kind of commodity hardware to store this cache. So cache is very important if you really your requirement is high performance. And extreme scale, WebSphere extreme scale or WXS is one of the solutions for that. Moving to next point, do the proper load testing. Again, lot of issues can be avoided. A lot of performance issues can be avoided if we do really proper load test. Again, one of the common questions that people ask me that, okay, if I want to do a load test, what kind of environment should I have? Can I do it on my UAT? Can I do it on my entire production? So ideally, you need to have production-like setup, but I understand you cannot have the same kind of hardware for your performance test. So you can do the performance test on the subset of your production setup. You can bring down the environment. I mean, you can scale down the environment, and you can do the performance test. So when you do it, make sure let's say your workload is X, and then you have a sizing or you have capacity to support the X volume. When you make that, when you reduce your hardware to do the performance, make sure you reduce your workload also, so that you can do the performance test on the sort of identical scenario. But also at the same time, make sure that the database system or your network and these are the factors which are going to be the same, right? Because database, you need to make sure that when you extrapolate this result, your database is able to handle the same amount of workload. So make sure if you reduce or if you scale down the setup, you need to understand the database is also going to impact. Some of the best practices for doing the load testing is keep a track of all the tests and the parameter that you have tuned. Make sure that whenever you change one parameter, change the parameter only, once at a time. Don't change too many parameter and then run the load test. So have enough time planned for your performance test, because ideally in one day probably you may have to just run 2 or 3 iteration of performance test. It depends on again the volume and sort of environment. But make sure you properly document all the tuning parameters, because that is going to be your entry criteria for the production tuning. Coming to the last point, so I'm going to talk about use the right monitoring tool and problem determination tool. So coming back to our earlier discussion, we have IBM Support Assistant. Use the IBM Support Assistant to get all these tools and then use it for either monitoring or use it for the problem determination. So have a proper monitoring tool for the live monitoring. When you are doing the performance test, have PMI enabled, collect the data from PMI and put it in the report. Use the proper problem determination tool. For example, in the performance test, if you get out of memory error or something like that, use the proper tool to analyze it and keep everything recorded. Because once you conduct this and then you go to a production setup, there will be, if you see any issue at the production, you will have a lot of references here, So use the out-of-box tool like PMI, TPV. There are advisors also in the WebSphere application server. And then use additional tools which are IBM Support Assistant, which are free. And then for the enterprise level, use some tools from ITCAM. ITCAM is IBM Tivoli Composite Application Monitoring. It's a Tivoli tool. So these are the standard tools that are part of IBM Support Assistant, which are the free of. So there are many tools which are JVM related. There are many tools which are configuration, VAS configuration related. Some of the tools are related to tracing and the log analysis. Before I conclude, let me take it to some of the backup slide which I have. I was not very sure if I will be able to get in there. So I have some tools screenshots here. Okay. Are you able to see it? Okay, it's taking time for me. Okay, so this is a PMI and TPV screen. If you look at it is admin console, so it's not really a new tool that to buy it. On the left side, you will see the monitoring and then you will click on the current activity. It will show you the Tivoli Performance Viewer. And in the center there is a tree where you can select whether you want to monitor web container or connection pool or thread pool or anything. And then on the right side you will be able to see those monitors, and then there is a chart. So TPV shows the data for some amount of time. Again, those are the configuration settings. But on an average, you will be able to see 20 to 30 minutes of data here. So you can do some kind of analysis on the TPV data. Health center, I was referring here, so let me quickly show you the health center thing. Okay, so on this screen, I'm at slide number 29 in fact. The left screenshot is about the IBM Support Assistant, so ISA. So this is the workbench which provides you all the tools, and not only tools, it provides you much more than that. It is a support workbench, so anything which is related to IBM support, you will be able to find it here. So there you will see there is a find information, and then there is a analyze problem, and then third point is about the collect and send data. Find information is sort of a single point where you can search and get the information from IBM support. So anything which is available in IBM support documents or anything which is available in the forums, you will be able to get that information. When you click on the analyze problem, you will see that the front window, which is like whatever tools are available with the ISA. And in this case, I was running it on my machine. I had very few tools. I installed only tools. So I could see all the available tool here. So in this case, I clicked on the Java Health Center, which is the profiling tool, or basically it gives you a lot of functionality. One of the aspect is about profiling. When you start the health center, it asks you to connect to the running WebSphere app server. So when you say it brings the connection wizard, when you say next, it goes and connect it to running VAST server and collects all the JVM data. There is one prereq on the WebSphere app server so that health center can connect, and it's not a very big setting. It just you need to enable -x health center on the JVM properties. And all the libraries are already integrated in the WebSphere. So it just connects and gives you all the data. Now when it connects, bottom you will see that it is connected to localhost at port number 1972. So it basically have a live connection and it's collecting the data from the running WebSphere. Now it gives you a lot of information about JVM. One is it talks about what classes are loaded, all the detail about class loading. It gives the environment. It gives the garbage collection data. It tells you what was the heap utilization and all those things. It gives you IO details. It tells you how many files are being open, or it gives you even what files are open and closed and all those things. Locking any deadlock kind of situation, you will be able to get information here. Native memory also, you will get information here. And then next is the profiling. So my next screenshot is about the profiling. So here is the same screenshot. When you select the data, it gives you a profiling view. Then you give your application package name, and it will filter it and show you your application related data. You can use the health center even there is a number of, when there is a load. It doesn't need to be with a single kind of scenario or single use cases. When you are running a performance test, you can still connect using Health Center and understand how your application is behaving. So Health Center is quite optimized to run with the concurrent user also. It is point is that it has less overhead. Not you can certainly run in the performance test environment. So with this, I am almost towards the end of my presentation. See, what I tried to cover here is, some of the performance tuning recommendation like thread pool, connection pool, JVM. Then I spoke about some of the application level best practices, plus some of the caching. And then we spoke about some of this tooling. So out of box tool we have like PMI, TPV, and then we can go ahead with the IBM Support Assistant tool set, which are again free of cost. And these are really good tool. Lot of is easy to use. Especially health center is quite easy to connect and use. Gives lot of information about your environment, application data, and all those things. And so those are the topics I covered. I know that 1 hour is certainly not enough for talking about a lot of things in detail, but you can use this Developer Works community, and you can post your question, or if you need any more information in detail, probably you can post it there, and we'll get you that. So with that, I'll hand over it to Lalita.
Yeah. Thank you very much, Vishal. That was a lot of information on the performance related tool, especially the IBM Support Assistant, which has a huge set of tools for performance analysis and problem determination. So thanks everyone for listening in. Let me give a quick prelude to what you have in store for the rest of the day today and for tomorrow. So there are blogs from subject matter experts related to platform messaging and related to Web 2.0 that are posted on the community as part of the event agenda today. Please go ahead and review them and let us know around if you have any comments on them. There's a blog sprint running through the 3 days, so you can please post in your responses and comments to those blogs. Next, we have a video recording on Web 2.0 and mobile feature pack. So you can go ahead and see that and view that, and let us know if you have any posts around that. If you want to talk more about that, you can blog around that as well, as there is a blog sprint running. So this video recording from the expert has just been posted on the community. Please go and take a look at it. Then tomorrow morning's webinar at 11 a.m. will be on IBM Workload Deployer, IWD, which was earlier called WebSphere Cloudburst. Now this is for the patterned deployment, and Vishwanath from the team will be talking more about it. So this is for knowing the predefining the patterns that you can use to deploy. Because the can be deployed in various patterns, various topologies. So please don't miss this session. Please attend it